Hello everyone, my name is Chris Kim, and in this video we're going to talk about the application client by the Beaker framework. So what is an application client? An application client is a convenient tool for deploying and calling Algorand smart contracts. In the pre-Beaker days, developers would usually just use the Algorand SDK or the Goal command line tools to deploy Algorand smart contracts. Although the Algorand SDK and the Goal command line tools are powerful tools that let you directly work with the Algorand protocol, it's not the easiest thing to use. To get to the deploying and calling part of the code, you have to set up a lot of helper functions to make that happen, such as a helper function for creating an application, compiling the source code, and more. I showcased the comparison between just using a bare Algorand Python SDK and using the application client for Beaker in the What is Beaker video, so if you haven't checked it out yet, make sure you go check it out. The application client abstracts away all of these complexities so that you can get straight to deploying and calling your smart contract. Let's dive straight into the code example and see what this is all about. Alright, we're inside the application client AlgoKit project, and we're looking at the contract.py file which has our smart contract in it. So I'm going to use this smart contract to showcase what you can do with the application client. Here we're importing in some of the necessary stuff. And first we're going to define a class called userCounter, where I'm going to define all of the states that I want for this smart contract. So inside the user counter, we have two local state values defined, one user and one count. The user local state has a steel type of bytes, and it's going to hold the username of the account. And the count local state is a UN64 type, and it will keep track of the counter, and it has a default value of 0. Alright, coming down here in line 22, we're instantiating the application class to create this application. We're naming it userCounterExampleApp and is accessing the userCounter class to access all of these local states that we have defined up here. Alright, now let's go through the contract methods. First, we have an opt-in method defined and it has the decorator app.optin to indicate that this method will be called when the onComplete application call is an opt-in application call. It takes in one argument called username, which has an ABI.string type, and is returning a sequence where first we're initializing the local state of the account. So this will assign the count value to 0. And then we're going to set the user local state of this account to the username argument that we pass in. Then we have the increment method, which is an external method, so it's exposed to the ABI. And here we have an authorization logic where it's saying that only the accounts that opted into this smart contract can call this increment method. And all this increment method is doing is doing app.state.count, so it's accessing the count local state and incrementing that value by 1. Alright, down here we have a closeout method and it has a decorator app.closeout. So this closeout method will be called when the application call has an onComplete set to closeout. Here I have bare set to true because it's not taking in any arguments. And I'm just going to approve this transaction and not do anything else. Last but not least, we have the delete method, which has the app.delete as a decorator. So this will be called when the app call has an onComplete set to delete. Bare is set to true because it's not taking in any arguments. And here we are only authorizing the creator of the smart contract to be able to call this method, because you don't want anyone coming in and deleting the smart contract whenever they want. And again, we're just going to approve this method call and not do anything else. Alright, now let's go to the deploy.py file where it has all of the code that is going to use the application client to deploy and call that counter smart contract that we just saw. So first, we're going to import in the localnet module that we talked about in the previous video, the client, which is for the application client, and some const value for convenience. And then we're going to import in the app instance and the increment method that we defined in the contract.py file. First, we need to build and export the app that we created. So we do app.build.export, and we're going to export the artifacts to the artifacts folder, which is this folder right here. Now, I already have all the artifacts written in the artifacts folder because I already ran this file. But if this is your first time, even if you don't have the artifacts folder, this line of code will automatically create the artifacts folder for you and write in the 4 artifacts in that folder. Alright, now we're going to use the localnet module to get the local accounts that we have in our private local net. And then we're going to get the first 2 accounts and assign them to account 1 and account 2. Then we're going to use the localnet module to set up our AlgoD client. And down here, we're going to do client.applicationClient, and we're going to pass in 4 arguments. For the first argument, we're going to pass in the Algorand client we have set up over here. Then for the second argument, we're going to pass in the app instance that we have. And for the third argument, we're going to pass in the address of account 1 as a sender and the signer of account 1 as a signer. So let's break this down a bit here. When you want to create and call your smart contract, you need the Algorand client to be able to talk with the blockchain. You need the app instance so that you can interact with the app. And you need the public address and the signer object to be able to send transactions and sign transactions when you're calling the application. So by having all of these information included in the application client, later we'll be able to easily deploy and call our smart contract with our app client. So we're going to assign the created application client to app client 1. And down here, we're going to use our app client to create the application. And just like that, with app client 1.create, that's going to create our counter smart contract, and the creator is going to be this account 1. Now running this code will return 3 values, the app ID, the app address, and the transaction ID where the app got deployed. So we're going to print those 3 values out down here. Moving down, and from here on, I'm going to call the methods that are defined in the application client class to showcase what you can do with it. So first, we're going to use the application client to get the application account info. Now remember, Algorand smart contracts are also accounts. So they have an address, they can send and receive assets, just like any other account. And we call these app accounts or application accounts. So we're going to print out their application account state like that. And then we can use the application client to fund the smart contract. Now this is useful when you need to have some algos in the smart contract for MBR or minimum balance requirements, or for other cases where the smart contract needs to have some algos to send to other accounts. So here we're going to do 1 times const.algo. So I'm using the const module here to easily write 1 algo instead of doing something like 1 million microalgos. It's just easier to read that way. All right, and then down here, I'm going to call get application account info again, but this time I'm only going to print out the amount value inside of the dictionary that this returns. So we should see 1 million microalgos printing out right here. We can use the app client to opt into the smart contract by doing app client.opt-in. Now if we go back to our contract and look at the opt-in method, you can see that it takes in 1 argument. So going back to deploy.py, that's why we're passing in the argument username here like this. If the opt-in method is a bare method, you would just do opt-in with no arguments passed in. And here I'm going to pass in Chris as my username. Here I'm doing app client 1.prepare, and I'm passing in account 2 signer as a signer object. So what prepare does is it lets you create another application client with all of the same Algorand client and the same app ID as the first application client. So if you come back up here and look at app client 1, this application client already has the Algorand client and the app instance defined in there. So by doing app client 1.prepare, this is going to use those same values and just change the signer object so that this app client will now be used by account 2 and not account 1. So we're going to assign that to app client 2. And I'm going to use app client 2 to opt in that second account, and I'm going to pass in Ben as the username for this one. All right, now let's call the increment method. I'm going to use app client 1, so the first account is going to call the increment method. So this is how you would call external methods using the app client. And for app client 2, I'm going to call the increment method twice just to show the difference. And then here, I'm going to use the app clients to get the local state value by doing app client 1.get local state. So this is going to return the local state of account 1 and local state of account 2 for this one. Now down here, I'm using the app client to close out from the smart contract. So closing out is basically opting out of the smart contract. So by doing app client 1.closeout, this is going to erase all of the local states that were stored in account 1 and disconnect that connection between account 1 and our smart contract. I'm going to do the same thing for app client 2. And I'm going to use app client 1 to delete the smart contract because account 1 is the creator of the smart contract. And if you remember, our delete method had the authorization logic that only allows the creator of the smart contract to delete the smart contract. So as you can see, you can do a lot of things with the application client. You can create an application, you can fund the application, you can call external methods, you can opt into it, close out, and delete. And you can even update the smart contract if you made the smart contract updatable. All right, now let's head to the terminal and run this file and see that everything works. So going to the terminal, and I'm going to run python 3 deploy.py. And boom, just like that, we deployed the app and printed out the 3 values, the transaction ID, the app ID, and the address. And here, when we return the application account state, it returned a dictionary of all these values. So it has the address of the app account, the amount of microalgos it holds, pending rewards, minimum balance of the smart contract, and so on. And then we funded the smart contract and called get application account state again, and we only looked at the amount value in the dictionary. So this returned 1 million because we funded 1 algo. So that looks correct. And for all the rest of the things, you can see that we successfully opted in. We incremented the counter for Chris and Ben. And when we got the local state of account 1, we see that the local state count has a value of 1, and the local state user has a value of Chris. And for account 2, the count value is 2, and the user local state is called Ben. And we were able to successfully close out and delete the application. In this video, we learned how to use the application client and what you can do with it. With the application client, you won't have to manually construct every single transaction and define helper functions that construct, sign, send, and wait for confirmation. As always, if you have any questions, head over to the Algorand Discord channel and ask your questions, and the developer relations team or the Algorand developer communities will help you out. That's it for today. I hope this video helped you out to understand what the application client is, and I hope that it will help you build your project on Algorand.